Hello everybody. In this Python tutorial, we're going to go over how to calculate the present value and the future value. A few notes before we get started. The present value is the value today of a future payment or payments discounted at some rate. The present value method can be used to determine how much money should be invested today to result in a desired amount in the future. For example, the present value of $100 to be received 10 years from now is about $38.55. Using a discount rate equal to 10% interest compounded annually. Another way to think of this is that you would need to invest $38.55 today and receive 10% interest compounded annually to receive $100 in 10 years. The present value method is widely used in corporate finance and security investments to help make decisions about investments. Note that the answer for the present value function shows a negative, and that's because it's considered a cash outflow or an investment. It comes out of your pocket, so to speak, and goes into the investment. Okay? The arguments for the present value function are shown here, and they include the rate, that's the interest rate, the number of periods, and that includes the number of periods that the investment will earn interest, and compound, and we'll go over examples of that, the payments, if there are any, the future value, and the when. And depending on what you're trying to figure out, not all of these arguments have to be put in. So for example, you don't have to put in a payment or a future value, but you have to put in at least one or both. And you don't have to put in the when argument, but if you don't put that in, I believe it will default to the end or zero. And we'll talk about that more in our specific examples. Okay, so let's go ahead and get started. The first thing you want to do is import the NumPy extension. And here we have our first example. So you want to make an investment. You will invest for 15 years. And we need to do something special with the number of periods. And we'll go over that in just a second. You want to have $150,000 at the end of the investment. That's the future value. You can contribute $200 to the investment at the beginning of each month. Over the next 15 years, the investment is expected to earn an annual interest rate of 4.5% and earns interest on a monthly basis. And that earns interest on a monthly basis. That's important to know, and that will determine how we put in our interest rate and our number of periods. Okay, so let's go over our arguments. As we mentioned in our example, the investment is expected to have an annual interest rate of 4.5%. But we can't just put in 4.5% here for our rate because the investment earns interest on a monthly basis, or it compounds on a monthly basis. So in order to get the correct rate, we need to take that 4.5%, we put that in as a decimal, 0.045, and since that earns interest on a monthly basis, we divide it by 12. And we do something similar to the number of periods. So since our example said we have 15 years to invest, we put in 15, but since the investment earns interest or compounds on a monthly basis, we need to multiply that 15 by 12 to get the correct number of periods. Okay, so our next argument is the payment, and in our example, we said we can contribute $200 to the investment at the beginning of each month. So for that, we're going to put in a negative 200, and you put in a negative because that's coming out of your pocket, so to speak, and going into the investment. The future value of the investment, what we expect to have at the end, is $150,000. So we put that in for the future value here. And for the when argument, we said that we're going to contribute $200 to the investment at the beginning of each month. Okay, so the when can either be beginning or end, and you can type in begin or end, or if you don't want to type in begin, you can put in a 1. That's why we put in a 1. And for the end, you can put in a 0. So the next thing we did is we created a variable. Then we use our NumPy extension, use a dot to access the present value function, which just shows up as PV for present value. And then inside the round brackets, we put all of our arguments. And remember that the arguments in order are rate, number of periods, payment, future value, and when. So we put in all of our arguments based on these values here. Then we use a print to display the final answer, and we used a round function to round this off to 2 decimal places. So let's go ahead and select our code and run it. And you can see over here in the console we get our answer. The expected answer is here, $50,227.88, and what we got in the console matches, so we're good to go. Okay, one thing to note, you'll see that this answer is a negative, and that's because this is the amount that should be invested today to receive the $150,000 that we expect in the future. Okay, so we need to invest $50,227.88 today, along with our monthly payments of $200, and at this interest rate, with this number of periods, and so on, to get our $150,000 that we expect in the future. Okay, so let's move on to our example number 2. What is the present value of an investment that needs to total $15,692.93 after 10 years of saving $100 every month? Assume the interest rate is 5% annual, compounded on a monthly basis. Okay, so now we can start to plug in the numbers for our arguments. We said that the interest rate is 5%, so we put that in here. And again, since it compounds on a monthly basis, we need to divide that by the number of months in the year, which is 12. The number of periods is 10 years times 12 months, because we said we have 10 years to invest. And since it compounds on a monthly basis, to get the total number of periods, we take 10 years times 12 months. We said that we can save $100 every month, so we put in $100 here for the payment. And again, that goes in as a negative because that's a cash outflow from our account to the investment. The investment needs to total this amount here, $15,692.93, so we put that in here for the future value. And for the when, we're just going to use a 0, and the 0 is the same as end of the period. So here we created our variable. We used the NumPy extension, a dot to access the present value function. We put in our arguments, the rate, the number of periods, the payment, the future value, and the when. Then we use a print to display, and we use the round function to round this to 2 decimal places. So let's select our code and run it. And you can see we get an answer of $100. Okay, so that means we need to invest $100 today, along with our monthly payments of $100. We need to invest for 10 years at an annual interest rate of 5%, and the interest compounds on a monthly basis. Okay, so now let's move on to the future value function examples. You can think of the future value as the present value in reverse. The arguments for the future value function include the rate, the number of periods, the payment or payments, the present value, and the when. And again, for the when, you can use begin or 1, and for the end, you can use end or 0. So just like for the present value, to use the function, we need to import our NumPy extension. And let's go ahead and get started with our first example here. This is very similar to our previous example. You want to make an investment. You will invest for 15 years. You have $50,000 to set aside for the investment today, and you can add $200 to the account at the beginning of each month. Over the next 15 years, the investment is expected to earn an annual interest rate of 4.5% and pays interest on a monthly basis. So here for the rate argument, we put in 4.5% as a decimal, but since the investment pays on a monthly basis, or it compounds monthly, we need to divide that by 12. For the number of periods, we have 15 years to invest, but again, since it pays on a monthly basis or compounds on a monthly basis, we need to multiply that 15 years by the number of months in the year, which is 12, to get the total number of periods. We said that we can add $200 to the account at the beginning of each month. So for that argument, we're going to put in a negative 200. So it comes out of our account and goes into the investment. That's why it's negative. In our example, we said that we have $50,000 here to set aside for the investment today. So we put that in for the present value. And again, that goes in as a negative because we're taking that out of our account and putting that into the investment. And we said that we're going to put our payments in at the beginning of each month. So for the when, we're going to use a 1 for begin. So next, we created our variable, and then we used our NumPy extension, a dot to access the future value function, put in our arguments, used a print to display, round this off to 2 decimal places, select our code and run it. And you can see our answer is $149,553. And this is the expected value of the investment after 15 years, according to all of our criteria here. Okay? Now just to show you that the future value is the present value in reverse, recall that our answer from the present value, first example, here, comes out at $50,227.88. Let's take that amount and plug it into our present value for this function. Now if we plug this in and select it and run it, you can see over here in the console we get $150,000, and now the present value and the future value numbers for both of our examples match. Okay? So if you play around with that a little bit, you'll see that the numbers match. So now let's go over our future value example number 2. What is the future value after 10 years of saving $100 now with an additional monthly savings of $100? Assume the interest rate is 5% annual, compounded on a monthly basis. Okay, so for the interest rate, we put in our 5%, but since it compounds on a monthly basis, we need to divide that by 12, which is the number of months in the year. The number of periods, we have 10 years to invest. But again, since it compounds on a monthly basis, we need to multiply that by the number of months in the year, which is 12, and that will give us our total number of periods. Here, we said that we're going to put in an additional $100 a month, so we put that in here for the payment. Put that in as a negative because that's coming out of our pocket, so to speak, going into the investment. We said that we're going to put in $100 now, so that goes into the present value figure here. And the when, we'll just put in a default of 0. Use our NumPy extension, dot, to access the future value function, put in our arguments, print to display, round it to 2 decimal places, select our code and run it. And you can see we get an answer of $15,692.93. Now again, just like our examples here and here are very similar, and you can think of them as the reverse of the other, this example here is the reverse of our second present value example here. Okay? So this $15,692 is the expected value of the investment at the end of the investment. Okay, so that's all we have for this Python tutorial on the future value and present value functions. We will be doing many more Python tutorials in the near future. Join us for those, and we'll see you next time.